Welcome back to part 2 of Algebra 2, topic 34, logarithm basics and evaluating logarithms. So, something that I want to mention is that there's such a thing called a common logarithm. So, if we do not see a base, it is assumed that we're automatically going to have a base of 10. So, we can assume that log base 10 of x equals log of x. There's automatically going to be a 10 there. If we see another number written in the base location, then we will go with that number as the base. But if not, we assume that there's a 10 there. So let's use that information to solve a word problem. So the wind speed S in miles per hour near the center of a tornado can be modeled by S equals 93 log of D plus 65. And again, this is going to be log base 10 of D, where D is the distance in miles that the tornado travels. In 1925, a tornado traveled 220 miles through 3 states. Holy cow. We're going to estimate the wind speed near the center of the tornado. So we want to determine what S is. We are given the distance right here in our problem, 220 miles, that is our distance. So we have our function of S equals 93 log base 10 of D plus 65. And instead of D, we're going to rewrite 220. So we're going to plug that in. So we are substituting 220 for D in our function. So what we need to do now is use a calculator. You can use Desmos, you can use your graphing calculator if you have that on, but as soon as you plug in log in a calculator, it is automatically assuming that you are using a base of 10, so you don't need to do anything here. So let's go to our calculator. Okay, if you're using Desmos, in order to put the log in, you need to tap on the function button, and then it will come up right here. So we're trying to determine the log of 220. And we know that is 2.342422681. So let's just put that to the thousands place. So we'll have S equals 93 times 2.342 plus 65. Now what we're going to do, we're going to use order of operations, use PEMDAS to simplify. So we're going to do our multiplication first and then our division. So you can go back to your Desmos. And since we have this number here, Desmos is really handy that you can do answer. Oops, we're not there. Let's clear that. Okay. We can use our answer from beforehand, multiply it by that 93, get our new answer of 217.8453093, and then after that, we are asked on our PowerPoint to add 65 to that. So we're going to go back to our Desmos, take that answer, and add 65 to that, and get our new answer of 282.845 here. So S here equals 282.845. 8, 4, 5. So that is our value. Then, because we're solving a word problem, we're going to write our answer in a complete sentence. So the wind speed of the tornado near its center is 282.845 miles per hour. And there's your word problem. Okay, let's talk about inverse functions. So inverse functions are like opposite functions. Think about it, if you have negative 6x and positive 6x, those are inverses. They will undo each other. So here, our inverses are g of x equals log base b of x and f of x equals b to the x. So these two functions will undo each other. So let's see this in action. Remember composition of functions? So if we take g of f of x, so my outer function here is going to be my g of x. So we're going to have log base b. Now instead of x, this is where I'm going to have my inner function, my b to the x. Whenever you see this, it will be equivalent to x. Because our bases match here, this will cancel, and we will just be left with my exponent. If we were to do the other way, so for example, if we were to have f of g of x, here we have b to the x, which is going to be my g of x, which is going to be log base b of x. That is also going to be equivalent to x. So whenever these match, they will reduce, and we'll just be left with that value right there. So we're going to keep these two composition of functions in mind when evaluating the next two expressions. So our first example is going to be 10 log of 4. So remember, when we don't see a base, we're automatically going to assume that this is a base of 10. So we can rewrite this as 10 log base 10 of 4, and we want to figure out what this equals. Here, because we notice that we have 10 raised to the log base 10, this undoes each other, so we're just going to be left with 4. So this just equals 4. Now if we have the next problem, log base 5 of 25 to the x, we want to determine what this equals. So let's rewrite it. This can be rewritten as log base 5, but our 25 can be rewritten as 5 squared to the x. Notice here how our base and then our number here match. So we can simplify this further by using our properties of exponents and rewriting this as log base 5 of 5 to the 2x. So remember, whenever we have a power raised to a power, we multiply them. Now, since these match here, they reduce, and we're just left with our exponent of 2x. And there you have it. So your homework is going to be quizzes, topic 34, evaluating logarithms, and is located online. Thank you so much for watching.